Math 7, Unit 4, Percent and Proportion, Lesson 6, Part 2, Tax and Discount Notes. So on page 66 in the notebook, things we're going to be covering in this lesson. I can use the percent proportion and the percent equation to solve percent problems. I can calculate the percent of a number, that's just part of doing these problems. I can solve percent of change problems, including finding percent of change, new amount and original amount. Tax and discount problems are just finding new amount and original amount. Sometimes finding percent of change as well. You can calculate tax, discount, markup, and simple interest. Simple interest is not happening in today's lesson. I understand the relationship between various percent situations. So, a little bit of vocabulary. First, discount. Discount is the amount of decrease from the usual price of an item. Can be given as a percentage of price or a dollar amount. For example, you could get a $5 discount with a coupon. That is not a percent, it's just a dollar amount. You could get a 5% employee discount. A lot of times discounts are given as percents though. Markup, the amount added to the cost price of an item or service in order to cover operating expenses and profit. Can be given as a percentage or cost or dollar amount. So $15 markup on a car part, okay, that's just given as a cost. 35% markup on a calculator, that's 35% of whatever the original price was. 175% markup on jewelry, which for jewelry, that's actually about what it usually is, somewhere around 200%. Sales tax is a percent markup on an item assessed by a local or state government. For example, 6% sales tax will make a $1 item cost $1.06. It increases the price by 6%. So doing increase or decrease by a percent, these problems are of the form blank increase by percent or blank decrease by blank percent. So 13 increased by 30%, there's the example of it. What is $65 discounted by 60%? You find 60% and subtract it off. We're also going to be looking at problems where a blank percent discount gives a sell price of blank, find the original. These are a little bit more challenging. What you have to do on these is find the percent that you're actually paying. And here it's explaining it using an equation, which is a good way of doing it. Go ahead and move on to the examples though. I am going to demonstrate a little bit with ratio tables as well. In a ratio table, as this one is, I've got my value versus my percent. So in this column are going to be the values and the percent. The top one is the original, and it is always the 100%. We've got the amount of change that either adds or subtracts, and we get the new. Now, the thing is, these, as you move down the table, it either adds or subtracts depending on what kind of change you have. But across the table, these are always proportional. Which is very helpful. So determine each percent discount or markup. A $55 pair of shoes on sale for $22 at a clearance sale. What's the percent discount? This one's just asking for percent of change. We are told the original price is 55, the sell price is 22, and it wants to know the percent discount. Well, since it is a discount of $33, we just need to do, if $55 is 100, $33 is what percent? So we can do this as a proportion. Basically, since it is a percent of change problem, we just need 33 divided by the original, 55. And 33 out of 55, I think is going to come out 0.6. It does, 0.6. So this is a 60% discount. A jewelry store sells a diamond ring for $1,000. The cost of the store was $400. What's the percent markup? So the original cost was $400 and they sell it for $1,000. So we need to figure out the percent. The change is going up 600. Well, this is just 600 compared to the original 400. That's 1.5. So we move that over, and that is 150% markup. The jewelry store added 150% to the price they paid. Determine the sell price of the item. A $150 bike on sale with a 5% discount. What's the sell price? Okay, let me do it the regular way first. We would find 5% of 150, which is, I think it's $7.50. 0.05 times 150. Oh, I put 0.5. It is 0.05. And that is $7.50. So we take $7.50 off of it, and that will give us $142.50 would be the sell price on the bike. Now, using the ratio table, the original price is $150. The change is going down 5%. That means that we are actually going to pay 95%. So I just need to find 95% of 150. Well, that's 0.95 times 150, and that comes out to be 142.50. So the ratio table, when you have the percent information, you can do your adding and subtracting over there. Example 449. A store buys a computer for $200 and sells it to the customer with a 40% markup. What is the sell price? Well, we would find 40% of 200 first, and that is $80. We take the 200 and add the $80 to it, and we get, that looked kind of funny, $280. Okay, using the ratio table, the original cost is 200. It is a plus 40 markup, which actually means you pay $140, 140%. So we just need to know 140% of 200, and that comes out to be $280. Again, these add or subtract down, and they're proportional across, all compared to the original. Number 450. Determine the original price of the item, cost to the store. Okay, I'll do this two ways. The ratio table is actually kind of useful on this one. You can buy a backpack for $19.25. The backpack was discounted 45% off. What is the original sell price? Okay, the original price was discounted 45%. Giving a final price of $19.25. Okay, the original price minus 45% of the price is 55% of the price is $19.25. We divide by the 55% on both sides, and the original price before it was discounted is let's see, $19.25 divided by 0.55. Oops, I typed that in wrong. Is $35. So the original price was $35. Let's look at how you would use the ratio table for this. The original value we don't know. It was 45% off, and it came down to a price of $19.25. Now on this one, $19.25 is the new amount, and it is 55% of the original, let's call it X. Oops, that's not what I meant to do there. All right, divide by 0.55, and you get the same answer here, 35. It is $35. Okay. I need to actually get some space here, so I'm going to do some selecting and grouping and get it moved off to the side a little bit. Okay, example 451. A store sells a pair of shoes for $25. This includes a 25% markup. What is the cost to the store? The cost plus 25% of the cost equals $25. That's 125% of the cost is $25. If we divide by 125% of the cost, we get an original cost. I believe it's going to come out to be 20, but 25 divided by 125% is 20. So the original cost to the store was $20. Now, if you use the ratio table, we don't know the original amount. We know it goes up 25%, giving us 125%, which 25 is 125% of the original cost. So using the percent equation here, divide both sides by 125%, and I do get 20. So there it is, done a couple different ways. In the practice, on 1, 2, and 3, you are, 1, you're doing sales tax, 2, you're doing markup, 3, you're doing discount. And you've got one of each type, where the cost is missing, or the sales tax is missing, or the original price is missing. Number 4, you're doing percent of change using fractions. Number 5, you're going to order the integers from least to greatest. That reviews back to unit 1. I think there was a test question like that. Number 6, find the percent of change in the time it takes you to run a mile based on the 2 timers. Remember that a minute has 60 seconds, so you're going to have to do some fraction conversion. Number 7 talks about the difference between increasing and decreasing. And then 8, there's 3 different places that Megan could buy a dress to go to her brother's wedding. And we want to know which one is the best price based on all the information there.